For whom of you is it the first in-person conference ever? It's quite a lot of hands. Who of you is in Berlin for the first time? Also some hands. Yeah, thank you for answering. Thank you for coming to my talk. Thanks for coming to Keep Your Code Refactorable. I'd like to introduce myself real quick. I'm Garrett. I joined Accenture in 2016 as a dual student. I'm a software developer, and as you can probably tell by the picture, I like riding bikes. And I'm also quite a nerd in the Tolkien universe, so even if you dislike the content, maybe we can talk about that. So we have choices. And from here, I'd like to tell you what the plan for the next 30 minutes is. We start off with the what and why. So what is refactorable code? What it is defined at, and why should we do that? Why do we need it for? Before we go into a bit more detail on how we can achieve refactorable code, what really do we need to do in order to benefit from it? Before we finally close it off with a Q&A, where I invite you to share your questions, your concerns, your doubts, your experiences. Really happy to discuss all that then at the closing of the session. And here we go already. So we start off with the what and why. And I wanted to do some definition at the very beginning. So Martin Fowler, who's one of the signees of the Agile Manifesto, who also published quite a lot of books and articles, he gave a definition of what a refactoring is in his book with the same name. And he says it's a change made to the internal structure of software without changing its observable behavior. And what that really comes down to is that you're allowed to change whatever implementation detail you have, as long as you don't touch which business functionality you deliver to your users. So you could use Java 8, Java 17. Really, it doesn't matter whether you use Python or Java. It's all up to you. You can improve your code as long as it stays intact in terms of business functionality. So really, the idea is to improve existing code. And then on the other side, what I had in mind with refactorable code was more an environment that allows me to safely improve, but also extend my code. And this improvement part really maps to what Martin Fowler defines as a refactoring, so improving existing code. Whereas the extension part is more about adding new business features, making the application richer, while still having the safe environment, while still getting feedback, while still knowing that you're on track. So refactorable code really is a state of a code. It's a state of the application where at any given moment in time, I have this safe environment that allows me to improve and extend. And from here, we will dive a bit deeper, and for that, I need a little bit of setting. So who of you has been in a project where there was a lot of time pressure, tight deadlines? That's like twice the amount of arms. Were you ever asked to cut corners, stop writing tests, do the documentation at the end? We will just do a hacky workaround. We will clean up later. Does it sound familiar too? Oh boy, it does. Good, like not good for you, but good for me now, because that's exactly what I'll pick up here. And I was in a very similar project. There was a lot of time pressure, and what I was wondering about is, hey, what's really going on here? What do we do wrong, and what could we do better? And eventually, I thought, well, whenever we write code, there's always 3 basic steps. And the first one being the reading step. We draw a first technical map of where we are. We try to understand the what kind of classes and methods are involved, what kind of language features am I using, how's the code speaking to me. Where then in the second step, I'll take this technical knowledge and I put it into a business context. I try to understand why the code is the way it is, how it is answering my business requirements. And with that gained knowledge throughout the 2 steps, I then go ahead and make the actual adjustment. I add a new feature, I fix a bug, or I simply apply a refactoring as Martin Fowler defines it. And through any of these 3 adjustments, I will alter the appearance of the code. And that really means I have to read and conclude again. So it's a circle, it's an iteration. Or as I picture it, it's a wheel. It's a wheel that starts spinning with the very first iteration of code, with the very first functions we add. And then there's certain influences from the outside that impact how fast the wheel is spinning, how constantly, how quickly we can deliver functionality or not. And in this particular case, in this negative project experience, I think there were 3 main negative impacts that made the wheel become slower and slower and introduce more and more hurdles. And the very first one being pressure. If you have a fixed deadline and then you have a fixed amount of workload and you basically already know it's not going to fit into this deadline, you need to find the time elsewhere. You are basically asked to stop writing tasks. Don't do documentation. Find a workaround. Just make it work. And that eventually means that you will end up with a vicious cycle, because after that release, obviously, there's another one and another one. So the quality and the quality mechanisms of your application go lower and lower. They're really degrading, whereas the pressure stays high. And if that is a constant environment where we as developers work, we might get ignorant. We're putting in a lot of overtime to somehow make this project work. We are putting in a lot of time in order to make this functionality work, but nothing is getting better. I'm still doing overtime after weeks and weeks of work, and the quality is getting worse and worse. Basically, we are building a very bad product already. And then finally, that situation in a very severe state can lead to fear too. Because if there's low quality mechanisms and low quality in general, then there's a high chance of introducing a bug with every adjustment, with every contribution I make. So people might be afraid of contributing at all because there's such a high chance to just introduce more workload in the same time. And this is really a very, very bad environment to have because nothing is functioning properly. So I was wondering, what do we really have to do in order to make this better? What would be a positive impact to have for this wheel to start fast, spin faster, or at least at constant pace? And I eventually thought it's confidence. It's confidence as in when I read code, I really know I can be confident that I understood it correctly. I can be comfortable in the code that I work in. I can feel at home. I know where things are, just like in my kitchen. Confidence in making conclusions and trying to understand why the things they are, really knowing what the business requirements are and how they should be basically fulfilled, and why the code is the way it is. Confidence in adjusting the code when we're adding new features, that first of all, we are not destroying everybody else's code, and second of all, we are actually contributing in a positive manner. And I got this idea of confidence mainly by a person called Dan Norris, who coined the term behavior-driven development. And he wrote a blog post which he called "We Need to Talk About Testing." And in there, he describes the profession of a tester and how that is fundamentally different from what automated developer tests are. And what he says is the task of a tester is to speak to different stakeholders of the application and the product and grow their confidence that their stake is actually covered. So if you take the security department, for example, then testers talk to that department in order to write security or penetration tests, so these people become more confident that their stake is covered. And very similarly, we as developers are stakeholders of the application we write, of the code we produce. And therefore, we should also be looking out for confidence, because confidence can tell us whether we are actually on the right track, whether things are going to succeed, or whether we are just barely making the release and nobody knows why. And from here, I want to dive deeper. I want to explore how we can achieve refactorable code and really what the steps are. And we start off with the reading step again. So it's about the technical understanding, about understanding what is in front of me. So really about getting the first information, having an entry into the code, and then getting this feeling of comfortability. And I think the crucial part in order to have more confidence while reading the code is to produce more readable code in the first place. So really the confidence comes from the adjustment step and is moved over to the reading step. And that applies for me, but everybody else in the code. So the better the code is that we all produce, the easier it is to read. And really this reading code, getting the first information, is so crucial because software development is a team sport. We all do it in a team. Or as Tim Ottinger says, programming is a social activity. And he's so right. He said that in chapter 2 of the Clean Code book, when he talked about naming things like classes, variables, methods. And what he means is that if you don't find a pronounceable name for all of these things, you cannot talk about it. And if you cannot talk about it, you cannot collaborate. You cannot brainstorm. You cannot move forward efficiently. So really naming things, expressing information, giving it to the reader is one of the major points really to fulfill in order to grow the confidence. And now there might be one term that you immediately connect in your hearts with readable code, and that is clean code. But then again, I think clean code is a very broad term. Are we talking about really clean code, and what does it really mean? Is it readable code? Is it maintainable code? Is it simple code? So there's different nuances and interpretations, which is why I want to focus on these three main points. The first one being, if you put readable code to an extreme, you might as well just produce speakable code. And what I mean by that is, if the reader has to put in a lot of information to pull the information out of the code, to really decipher what was written, to understand what's happening in front of him or her, then that's wasted energy. Why not make it as simple as possible and push the information to the reader? Produce speakable code, speaking code. Find expressive names for all the things that we name. Think about in which context we use these things, what they can express in a common language within the team, and really how we can get information across. A variable called ABC might not be of much value, so really we can put in a lot of more time to make it more efficient. And I think that point goes hand in hand with the separation of concerns. And I want to explain that a bit more with an anti-pattern. So if you imagine a God class with 4,000 lines of code, and you're currently investigating a method at the very bottom, which is also connected to the instance variables at the very top. All you do is scroll up and down and up and down. It's really hard to understand. It's really hard to wrap your head around. I mean, imagine how we did screen sharing in the last 2 years, or pair programming, more to say. People are sitting in front of your screen, they have no chance understanding it whatsoever. So really, splitting things up is not only easier to understand in terms of size, but really you reduce the scope and the complexity that is connected to each of these pieces. So if you split things up more often and often enough, eventually you will end up with pieces where the majority of your mental energy is invested in really understanding what's going on instead of deciphering what the context and all these dependencies mean. And one beneficial side effect of breaking things apart is that eventually you will always have more parts than you had before. And that means you can find more explicit, more particular, more speaking names. You can give the names that match the scope, that match the concern of the parts you've just created. And that brings a lot of information and knowledge across. And then finally, and this is my favorite, I want to talk about a mindset that I call it works. I absolutely hate it, but I still have to fight myself about it every now and then. And I want to illustrate that with a picture. And this is a self-drawn picture by a colleague of mine, whose name is Holger Zahnleiter. And I think what we can all agree on first sight is that we see a house, right? At the second glimpse, though, we see a lot of problems. The rain pipes are off, they only hold in place by the broom, there's some nails in the wall, the entrance is in the first level with only a ladder, and then the chimney is off too. So there's a bunch of problems with this house. And what that really means is if we don't fix any of these problems soon enough, there will be other problems. If we don't fix the rain pipes, there will be water damages. And that puts the house into a state where adding any new feature, like a picture on the wall, has a high risk of making the whole building collapse. And now if we bring this picture back into the coding world, what I see which produces this is where the only thing you're concerned about as a developer is making things work. Checking the console for the expected value, you see it scores the value you expected, and you immediately push the code into the repository without a second thought, without refactoring, without writing tasks, without having documentation, without finding better names. And that really produces houses that look like these. We can all tell it's a house, but it's a very, very risky one. And from here, I already want to dive into step 2, so the conclusion step. Again, we take the technical knowledge that we just gained and we put it into a business context. We try to understand why the code is the way it is and how it's answering our business requirements. And for me, the crucial part in order to grow confidence in this step is to make each and everyone's implicit knowledge explicit. Share your knowledge, share your ideas, share whatever you learn with the application and in the domain. Because only as a team we can grow and build a meaningful product. Only if everybody is on the same page, even only if everybody is on the same level, we can really build products that are close to the requirements, close to the users, and therefore competitive to the market. And I want to dive a bit deeper on what methods there might be in order to share your knowledge within the team. And I think there's a bunch of them, so I only want to highlight 2. And we start off with tests and test feedback. So what we see here is an example unit test written in Java. And it has 4 properties. At the very top, we see the case description. Then on the left, I guess, on that side for you, we see the inputs. So they are called USD and EUR. Sounds a bit like currencies. And then on the other side, we have the output, which is of type double, and it's called rate. Could be the exchange rate. And then finally, at the bottom, we see the assertion with the expected output and the expected behavior. And none of you has any idea what this application is about. But reading only these 4 lines of code already tells us quite a lot about what we should expect and what this is about. We're not concerned about converting 5 euros to X amount of US dollars. We are concerned about the exchange rate. So really what we have here is some kind of technical documentation that somebody puts into the code and that everybody else can read. And it really gives us a feeling about what to expect of the code. And what's even greater is that everybody on the team, regardless of team membership, prior knowledge, technical experience, can execute these tests and get feedback. And the feedback is either green, then we know, well, what I just understood from these 4 lines actually makes sense and seems to work. Or it turns out to be red, but then we have a precise locator on where things are wrong and most probably also why they are wrong. But there's another great way to share your knowledge. And it's commit messages and a commit history. It's a path of thinking and learning for me. So what I brought here is an excerpt of a commit message by the person called DevVersion. He or she raised a pull request of a total of 74 commits on the Angular repository by Google. And he or she, with every commit, gives a great summary of what happened and why it happened, which approach was chosen and why it was chosen. And more importantly, at the very bottom, and I had to cut it off in order to fit it on the screen, there's a huge summary of approaches that just didn't work out. And that's great knowledge to have in such a distributed environment like open source, where you cannot just simply talk to one another. It is written down why maybe the obvious approach didn't work and what approach was chosen as an alternative. So this really is a great way to comment a bundle of changes, a commit, and make it more powerful by enhancing this with a great why. Why did things change? And from here, I think we are ready to adjust the code. We are in step 3 already. And for me, I always follow 2 goals here. The first one being, I want to make sure that the adjustment, the new feature I'm going to add, in itself actually works as expected. So there's some kind of feedback I need. But I also want to make sure that I'm not destroying everybody else's code. Yeah, I cannot just hang the picture on the wall and then the whole building collapses. So really the confidence here comes from the fact that I know that I'm on track for both of these goals, that I know that I'm following the right way and that I'm actually moving forward. And again, I have 2 things to talk about here. And the first one being, get some kind of guidance on the way. Whenever we develop, let's not develop into the dark. Get some kind of feedback that tells you whether you're still on track or whether you took the wrong way, which is not bad. Just start from scratch. And to emphasize on that a bit more, I brought a quote from Kent Beck. He's one of the other signees of the Agile Manifesto. He's also the creator of extreme programming and the inventor of test-driven development. And there's one funny line he gives in one of his test-driven development books, which is, one of the ironies of test-driven development is that it is not a testing technique. It is a design technique. Now, if you imagine what he says in that book too is, if you follow a test-first approach, there's nothing yet in your application. You cannot invoke a class. You cannot invoke a method. There's nothing there, only you and the test. What you're doing in the very moment you're writing the test is you're writing down, you're specifying your desired API. You're specifying the API you wish your code would provide. And that exact activity is called designing. And then from there, you start off with the implementation. You bring that thing to life, and from there you get a feedback. Because still you have this TDD test that at the end you can execute. You can check and get feedback whether the thing actually worked the way you implemented or not. And from here, really, we have a great basis to build further unit tests. Now it's ready to test the edge cases, null values, empty strings, blank strings, provoke some exceptions, care about the logging, really think about all the terms of behavior that your application really provides in that moment and get some feedback on that too. And that also a bit introduced the second thing I wanted to talk about here, which is kind of a step-by-step approach. Because whenever we work on a test, it will be one test at a time. And then you make a tick mark and you take the next one. And Jeepa Hill put this into the words of saying, make smaller steps. He wrote a blog post series of 5 articles where he explains why making smaller steps is the way to go. And his main message is, if you want more value faster, take many more, much smaller steps. And he even has a picture for that. If you imagine that you're currently here with your application, and this is where you want to go with a new feature, there's always the misconception that there's a straight line in between, and that you plan once and then just follow the straight line. And that's simply not the truth. There's always obstacles. There's always uncertainties. People might get sick, whatever. There's a multitude of reasons why things just don't work out as a straight line. And what he recommends instead is make a first step, learn from the first step, reevaluate, and take another step. It will not be a straight line, but it will still be the most efficient line, because with every step you learn and you can become better for the next step. And what I find interesting here is if you combine that with the tools we already have, with the version control, namely Git in most cases, we get a powerful tool to get a relief of mind. And what I mean by that is that with every test, if you make one test, you get the feedback and you commit. You take the next step, you make the next test work, you commit. Then what you will build up is a chain of commits and a chain of checkpoints, just like in video games. So if things go wrong, just throw away your work in progress, take the last checkpoint, and start all over again. So really that's some kind of relief of mind and allows you to focus more on the things you're currently working on instead of having this big bunch of work in progress to always have in your mind. And from here, I only want to come to a conclusion. So we explored a bit on what confidence is. Confidence as a driver to understand the code better, to have a better entry into the code, to have a feeling of comfortability in knowing where things are. Confidence as a feeling of knowing why the code is the way it is, why it's applicable in a certain situation, how it's solving the business requirements, how it's bringing the product forward. Confidence as some kind of guidance on the way when building new features and knowing that you're not just building some kind of improper houses. And I think with that, confidence really can create the safe environment that I mean with refactorable code. Confidence can really be, at any given moment, the driving factor to have the safety for improvements and extensions of our application. If we have, as stakeholders of our code, don't have the confidence to say this release is going to be successful, or we know what we're going to do next, then that's a warning sign, and we should react on that. And one final thing. This is not about us developers having more fun at work. This is not about fun while coding. This is real money and energy. If we think about how cutting corners is such a threat to an application, to a product, and eventually after 4 years you have to throw away the entire product because it simply became unmaintainable, then that's a huge waste of money and energy. And I think that's something we should prevent. I think we should thrive for more applicable, more meaningful, more competitive products by having a more competitive, and more meaningful, and more sustainable development approach. And from here, I'm ready for your questions. Thank you very much.
Thank you, Garrett. We have a few questions for you.
Sure.
First, what do you do when you need to refactor other team? When the refactor touches other team's code and they don't want to refactor it, they say something like, it works, why to change it, and stuff like that. So how do you convince people, for example, to switch from React class component to functional component to functional?
Yeah. The basic thing you will always need is some kind of feedback, always. So what Martin Fowler in his book called Refactoring says is, have some kind of test that just ensures that whatever you're currently expecting of this code to produce really verifies that, and then you have a safe environment to just change the implementation details and make sure that the same content is produced all the time. So that you will have one safety environment you build up, and then you're free to change whatever blocks you want as long as it still produces the same output. And that can then maybe convince people to say, well, yeah, this seems to work. There is some kind of feedback I get. I know I'm on the right track.
Okay, thank you. And when not to refactor code?
When not to?
Yeah.
If the product is about to die. So really, if there's no business reason, if there's no financial reason in the product, if there's a rebuild anyways, no need. Otherwise, I think there's always a reason.
And how do you put a balance between refactoring and urgent features?
That is exactly the line we need to draw. This is always basically somewhere to find a common level between, let's just say, the manager that pushes on the deadline and you as a development team that pushes for the feature and making things good. And making very clear that if we really go for the deadline now, we put the entire product at a high risk. And then it's about argumentation and finding a common ground. It's nothing that the development team can decide on their own if they are not in charge 100%, I think.
Okay. Thank you very much.
Thank you very much for having me.
Thank you all for attending the session. Our next
Enjoy your day.
will start in 5 minutes.